We'll start the session for today. And, let's open the module call first. We'll just recollect what we saw in the last lecture. I'm just trying to recollect what we completed in the last lecture, and then we'll start from there. Okay, so
Right.
I have seen the side panel options, advanced options, snap setting. Okay, we were there in this panel ribbon. That's it. All right, so I understood. Okay, let's start where we left. So it was a ribbon panel where we had stopped. Take some time to open that model. So before going forward, I think you are trying to tell me something about your understand. Means you are not able to understand the TEKLA.
Just to confuse them.
Hmm?
Just confuse them in the drawing.
It's okay. Means initially you'll find it difficult because you are not from that line. So maybe that's why
Yes,
you are
yes.
getting it difficult to understand this training. But
Yes,
slowly when you
yes.
practice, no, once you do the practice, so you will be able to understand the things. Once you
Yes,
go
yes.
inside the TEKLA, no, then you will find different things. You'll understand. Before that,
Okay.
now just for the lecture sake, you will not understand much in that. That's why
Yes.
we are recording the video, and then you will be able to see those videos if you want to
Yeah.
recall any command or anything. So you'll be able to watch that video and then understand what we had in the lecture. So it will be a good thing for you to that we have online recordings going on. So okay, we will start with the placing of grid now. Okay. Yes, last lecture I told you about the grid properties. So these are the grid properties.
Great.
Okay, grid properties were there. So in that I told you about that in X you have to add the dimensions which are in the X coming in the X direction, and in the Y direction you have to enter the spacing. So these are nothing but the spacing. and starting from the origin 0, 0, 0. So that is the origin. So initial 0, what you are seeing, that is a reference from origin. So 0 means that is a 0 in x means that is a 0 position at x direction. 0 in y means in y direction that is a 0, and in z means in z direction that is a 0. So that's why it is 0, 0, 0. Hope you are already aware of this concept. Our origin starts from 0, 0, 0. Okay. When we have any 3D model, have you done the graph and all those in the school? In your school time? Arul? Selvan? Arul? Arul Selvan?
Yes.
Are you there? Yeah. Have you done
Yeah.
heard about graph at your school time?
Yes, sir. Graph, I
Graph.
understand.
You know no graph?
Yeah. And I
In graph, what we used to do, we used to draw a x-axis like this. Um, like this x-axis, and then we used to draw a y-axis like this, right? In the school,
right.
in that graph.
Yeah.
So there will be a bottom left corner where we used to mark 0, 0, right? In the 2D page.
Yeah.
So that was a 2D, two dimension, 2D graph. This is a 3D. So in 3D, you will be having a x direction and y direction plus z direction is also there. That's why you're seeing here
Oh,
3, 0, 0,
yeah.
0. Yes, 3 direction. We are doing a 3D model, right? So BIM is a 3D modeling software. So TEKLA is also coming under BIM. So this is a 3D modeling. And in 3D modeling, we'll be having these 3 axes: x axis, y axis, and z axis. This is a basic of any engineering 3D software. If you're working or if you're learning any 3D software, henceforth, you will be following this coordinate system. This will be same in AutoCAD. Is also, if you go, if you visit or if you worked on AutoCAD, there will be axes. There also there will be origin, or there will be a 0, 0, 0 coordinate. In AutoCAD also it is there. Right? So we are following this kind of system in all the 3D software, 3D modeling softwares. So this is quite common nowadays in all the 3D modeling software, coordinate system. So TEKLA also works based on this coordinate system. It is very important for you to understand it, what the coordinate system
Yeah.
is. So this green box is the fixed global. This we call it, yeah, fixed. Green is fixed. We will not be able to move this. Okay. Green box. So this is fixed. This is called as a global coordinate system. Okay. And this red one, we call it as a local coordinate system. Okay. Local coordinate system. Right. So, and this local coordinate system will be able to manipulate this or change the location, change the direction. Okay. We can do anything in this, rotate or change the location. I'll just show you the demonstration demo on this, how this can be done. So just a small demo. You have to go in this ribbon and find view. Okay. On this ribbon tab, find the tab view, and under view, you have to go to work plane here. Okay. Under work plane, you have to find all these options are there. You'll find all the options. Work plane tool is there. Parallel to XYZ is there. Using 1 point, using 2 points, using 3 points, and parallel to view plane. So now I'll be showing you demonstration on this tools. Okay, how to use this tool. So now we'll try to change the location of this work plane. Okay, so using one point. So first I will show you these three options, how it is done. Using one point. When I click anywhere in this grid, say if I'm clicking here, you can see the work plane, local work plane position has changed. The origin is changed. So what does this mean that one point is the origin point. Okay, so when you click anywhere in the model, the origin of that local work plane will change, right? Like this. Okay. And when I use this one, this works in a different way. There are 2 points. So here you can read it as set the work plane using 2 points. You pick the origin point and the x direction. Okay. So these 2 points will define the x direction. So we can change the x direction of this view, right? How? I will just show you. Click here. And now you can see here, the x direction is in this way. I need the x direction in this way. Okay, so I will just click here. Okay, first point. So first point is given. I have to provide a second point here. And boom, you see, now it is changed.
Yes.
X direction is like this and y direction is like this. Okay. So origin x. So you see, now our global coordinate you can see x is like this and y is like this. The small letters you can see, the small letters.
Yeah.
So you can see this is fixed. This has not changed. But the local is changed now. Local x. This is big one is the local x, big X. This small x is the global X. So now local X, global X is not matching with the local X. So this is changed. Now we will use third option, that is using 3 points. Using 3 points. So how this works? Origin. Now here we'll see using 3 points will set work plane. Using 3 points we pick and the origin point, x direction and the y direction. So here we are going to give 3 points. One is for the origin. One is for the x direction and another is for the y direction. Okay. So I will just pick here. I will give the origin. See, now origin point is picked. It is asking me here for pick positive y direction. So I will pick a positive y direction here. Then it will ask me for pick point on the positive y direction. So this is the positive y. And here you can see now the work plane is changed, right? Okay. Did you understood this?
Yes, okay.
Huh?
Yeah.
You have any doubt?
Understood. Understood. No.
No, no. Okay. It's very easy. 3 points. And then now I will show you this one. Okay. Or I will say parallel to view plane. Now what happens? This is a view. This is a view 1, 3D. This is a view. So if I want to make it parallel to the view, so I can use this tool. If I click here, I need to click anywhere in the view, No, that means you don't need to click on any object or anywhere. Just click on the blank area. This is a blank area. You have to click there. I will click here and you will see it is changed to the view plane. It has gone to the original location. Now again, I will reset it to different location again, and we'll check the first option, this one, second option, that is parallel to XYZ. Okay, now I will say change, and you will see now it has changed to origin. It has came to the origin. Now what happened? When I use this option also, it came here. When I use this option also, it came here. Now in this case of 3D, this and this both are in the same location. Okay. Say if my view is something here, somewhere here, then this will be going at the top of the uh, so z axis will be changed, or maybe if view is your view is like this vertical. Okay, the plane will be like this. Say for instance, this is a grid. This is the grid plane. This is the grid plane. So it will match that plane. Okay? Try to match that plane, grid plane. It's our grid view. Now for plan, the plane is this way, okay, in X and Y direction. That's why you are saying it is matching the origin point of that view, particular view. Say if my view is generated, I will generate a different view and I will use some level in that, say 1000 or say 5000. I will click here 5000. Now my level, this is the Z coordinate. Okay, I just click here to create. Now you can see view is created. No? You can see here there is some view created, new options. Oh, I just closed all the views mistakenly. Okay, I'll create it again for you and vertically. Now here you can see this is the origin and this is a new view which I have created. So you can see grids are raised above now. Okay, 5000 and this is 0, 0, 0. Now what I will do, I will try to set parallel to view plane again. So I will show you what is the difference between this and this. So I'll click here. Now my view is here, starting on the 5000. So when I click here, you'll see the change, right?
Oh,
Did you see what happened? Now this view is set on 5000 because it is in the 5000 level, because we created this view on 5000 level, right?
right.
You understood?
Hmm.
So now
Yes.
for this view, my origin is here. For this view, origin is here. Okay, you can see grid is also there. No? Here also you can see grid is on the 5000 above. Okay, so I'm sorry. So when I double click on the grid, so this is my topmost level, that is 20,000. If I go beyond that limit, this is a limit, grid limit. Okay, if I go beyond that limit, you will not see any grid there. So grid final reaching point is 20,000. If I'm adding something here, say 40,000, so this will be the final limit of that grid, right? But for right now, it is 20,000. So grid will be, you will be able to see the grid till 20,000. Sorry. So what will happen here? When I create a view on 20,000 also, you will see the grid. Say I will give here 20,000. Okay. and you'll see a grid is there, 20,000. Because our grid is there till 20,000. So when I go here and create a grid at 20,001, still it is there. But if I add more 5,000, say 5,000, now you can see there is no grid. Why? Because
Oh,
yeah,
limit,
because the limit,
21.
it has crossed the limit. Our view has crossed the limit. So we'll not be able to see the grid here. But what will happen? I will go to this option, parallel to view plane, click here, and when I click here, we'll see now this is the grid, sorry, view is created by 25,000. So your view, when you use this option, it will the work plane will shift to 25,000. You can see here, it has crossed the limit. Okay, you'll see it has broken the limit of that view. Okay, you understood, no? This feature. Now it is clear
Yes,
for you.
clearly.
Okay, so now we understood how we are using these tools. Now, now all we have set,
Now,
say, what happened? We have set all these options.
yes.
Now we have to pull this back to the original place. So this original place is here. So I need to
Yeah.
pull it back. So I will use this parallel to XYZ plane. And here I have to say change. I can see it is going back to the original position. It has gone from here. Now you understood why this is used for and why this is used for. Both are different. Okay? Yeah, you're having some question? Please go ahead. You want to ask some question? Arun?
Oh,
Any doubt?
yes. Now,
Yeah, please
no
tell me.
doubt now, clear.
Clear?
Now
Okay.
understand.
Oh, good, good, good.
Yeah,
Okay,
practice
so
very important.
huh?
Like practice after I can understand everything.
Yeah.
I don't experience that feel.
Hmm. Okay, okay. Good. That excitement should be there because when you are excited to learn something, you will learn it easily. It will take some time,
Yes.
but you will learn it better. Okay. So I'll just open one sample which I had shared. I think I had shared in the group to you. This one, this document. So now we are uh, clear on the introduction part. So we'll start with this first topic, that is grid creation. Okay. Yeah, we'll start with this. And this is the sample model which we are going to create, right? A, B, C, and 1 and 2. Okay. So I will just do one thing. Let's try to uh, rearrange. Rearrange these windows. So we can see both the documents. So I want you to see PDF as well as TEKLA both. Okay, so now we are done. Hmm. Now here you can see we have grid A, B, and C, and then we have grid 1 and 2.
Okay.
Now here I have provided a reference like this is assumption. Okay, when we are in the
Okay.
model, we have to assume that your model is starting from bottom left. So that's how we created a graph in the school time. In the school time, we are
Yes.
using the bottom left corner to draw any graph. If you want to draw any graphs, we are using the bottom left corner. So same rule, what we had done in the school, same rule is there, bottom left. So this is the bottom left. If I want to say show the plan of this part, so I can double click here, plan view and modify. I can see this is a plan. There is also a shortcut for this. So when we press Control and P, I had shown in the last lecture, Control and P from the keyboard. When you
Control?
press Control
Sorry.
plus P from
Okay.
keyboard, Control plus P.
All right.
So
Yeah.
on keyboard you have to press Control plus P. Okay, so this is what you have to do in your keyboard. Okay,
Okay.
so I am pressing the Control and P here. So you can see the effect how in the TEKLA it is switching to plan and 3D with that effect. Okay,
No.
and same thing can be done through view properties also here. Same thing. It is one and the same thing. Okay, plan 3D
Great.
or plane 3D. Okay, there is one more option here: orthogonal and perspective. Orthogonal. Now we have to go to 3D first, and then go to orthogonal or perspective, and then you can see now 3D. Normally orthogonal will be everything is parallel. Okay, but in perspective, what happens? It is different. Perspective means, have you seen the video games or something like that? Virtual reality games.
No.
Okay, things will appear like this when you play any game, video game or something. So this is like a virtual, real this thing. Okay, a real view projection or real view projection. So when I draw a beam, I just draw sample beam here for you to understand that what this means. Just draw a random beam here for you. Um, just a random beam, and you can see how it
Yeah.
looks. Okay, so this is because of this effect, perspective. If I go for orthogonal,
Perspective.
it will look like a normal. Normally, how it is looking, it will look like that, normal. And this is how perspective looks. Perspective means it is like we are looking at the actual beam on site. Okay, when you are standing on site, you will be seeing like this objects. It is the actual representation of what our eyes see, virtual reality. Okay, so now if you are going to any site their advanced application of TEKLA. They'll be using this perspective images on site to understand different clashes or different material clashes or erection planning. They can plan out the sequences of erection with this virtual reality. They are they are now using Google Glasses, Google Lens. These are the new technologies now which have done collaboration with the TEKLA. Or TEKLA has introduced new tools on site. So on site, you will be seeing this model from your eyes directly on the site. Okay? So wherever there is any site, when you're moving in the site, you can see this beam also moving with you, like a video game. I don't know if you have heard about the virtual reality game where they are wearing the glasses. So this is the virtual reality. Are you able to see? Hello?
Yeah,
Yeah, something like this. Tekla has also introduced on site. So you'll be wearing this kind of glasses. And when you move on the site, you can see the beams and all those things. Um, Instead of these images, we'll be having the beams and columns. So you will be able to see the Tekla model on site like this in the virtual reality, which this is now been adopted by Tekla also. So in Tekla also they have this feature right now. So virtual reality in Tekla. So here you can see some Tekla guys are there. Now here you can see the piping and all those things. They'll be able to see the building, actually building on the site. So they can plan the activities there. Okay? Planning can be done, like what you are going to erect, where you are going to erect that, and what will be the clashes will be there. So you can see this guy is trying to zoom something in the virtual glasses. So when you're wearing the glasses, you will be able to see the model, 3D model on site. Okay. So this is a good feature, nice feature. This is related to AI. You might have heard already AI, artificial intelligence. Have you heard? So the cool feature now. This is already in used from long time for Tekla structures, respectively. But on the side, they'll be using this kind of view, not this one. So our eyes can see the clashes, or it can do the planning properly with those views. Okay, so